Well, good evening and welcome to Space Oddities. How are you all on this Tuesday evening? Thank you for joining us as always. Without further ado, may I introduce to you, we're honoured and pleased to have in the studio with us this evening, Mr. Jos de Bruijne. And he's from the European Space Agency, and he'll be talking to us a little later about Gaia. Now, you may remember if you were here last week that we talked about Gaia and the mission coming to an end. But we thought it would be nice to get somebody along who's actually worked on the Gaia project. And Jos is that person. So you are very welcome, Jos. Thank you for joining us. Okay. And apart from that, got the usual rabble here with me this evening. Roger, yes, looking rabblish. Yeah, well. Michael looking smug for some reason. I don't know what he's smug about. But the cat who's got the cheese. It's not cream. My cats, they don't like cream, they only like cheese. And we've got the wonderful Lou Mayo from the States with us. So how are you, gentlemen? Everybody okay?
Fine, thank you.
Life is good.
Well, this afternoon we ran a very special event here on Space Oddities. We joined 260 children in Yorkshire in the UK in 4 schools with 2 astronauts from the Polaris project, Sarah Gillis and Anna Menon, who flew on September's Polaris Dawn mission. And we got them together live here on Space Oddities so the children could ask them their questions. And we had an absolutely glorious afternoon, didn't we, with the children, guys? It was
Brilliant.
It was a wonderful experience, and it was so worth doing because they were so excited and into the whole thing. And the questions were brilliant as well, weren't they?
Oh, yeah.
Yep.
So we'd like to do this type of outreach a bit more on Space Oddities. But many thanks to Sarah and Anna from the Polaris project for joining us. And we hope we can meet up with them again at some point. So just let me play you a little clip of what happened this afternoon. Just a short clip, just to give you a taste of what it was all about.
Hello, I'm Cece from Southfield Primary. How was the experience to climb out of the spacecraft and test new? How did it feel to have a beautiful view of our world and where we live?
Did you get that question okay?
Sarah, I feel like you should answer this one.
Yeah.
That's a great question. So for the spacewalk, we all got suited up. We put on these incredible suits that the SpaceX team built and tested, and you get pressurized. And so they fill up with air, and it's like being inside a really almost hard structure. It becomes this thing you have to move in very certain ways. You can rotate your shoulder, you can bend your elbow, but you can't just freely move your arms in every direction because it's actually a pressurized volume that you're inside, and it fights you. It pushes back against you as you try to move in it. So we all got suited up, and then once we knew we had, like, the suits were fully pressurized, they were safe, then we started venting the spacecraft, and you open valves and all of the air starts being basically.
So there we are then. That's a taste of what we were doing this afternoon. The full video is on the channel, of course, called Meet the Astronauts. And many thanks to the 4 schools in Yorkshire for taking part, as I said, to Sarah and Anna for joining us. And we've been working on that with the Polaris project for 6 months. So it all came to fruition today, and it all went very well. And we're all very, very happy and even more relieved, to be quite honest, that everything worked. So there we are. Yeah. Okay, now let's have a chat with Jos. So Jos, can you just tell us a little bit about what you do?
Yeah, so I'm an astronomer by education. I've been employed by the European Space Agency. I still am since 2002 on the Gaia mission as one of the scientists there. So I've been working on this mission for 23 years now.
Wow!
And actually, we are not nearing the end yet. So indeed, there was a huge step taken a few weeks ago on the 15th of January. But it's an intermediate step in the whole process of the mission that is going to last until 2030.
Right, right. So how do you personally feel about the end of the observations? That must be, that after so long, that must be so disappointing for you.
Well, yes and no. So obviously it's disappointing because it's the end of a phase of a really, Gaia is a revolutionary spacecraft, a revolutionary mission, and it's revolutionizing astronomy. And this data that was taken on the 15th of January, it really marks the end of, let's say, collecting that scientific data. So that's sad. On the other hand, we were designed and supposed to live for 5 years in space with a potential 1-year mission extension. And all in all, we've been in space collecting very, very valuable scientific data for more than 10 years. So actually the nominal mission duration was doubled. So in that sense, the mission outdid itself by a factor of 2. So it's difficult to complain, right?
Yeah, absolutely.
Oh yeah.
Yeah.
For the benefit of our viewers who may not be familiar with Gaia, could you just give us an outline of what Gaia is all about?
Yeah, it probably sounds as the most boring thing you could ever launch, because it's simply a large binocular and a camera. So it's a telescope and a photo camera. The spacecraft is continuously spinning very slowly, so it's scanning the sky, and that's all it does. It's just recording star transits through the camera, so it's measuring when the stars are coming through, and it has been doing that for 10 years in a row. So it has been doing circles on the sky, 6 hours per circle, and it has been changing the orientation of the circle from day to day. So the whole sky was scanned every few months. And it has been doing that for 10 years in a row, and just collecting these star transit times. So that probably sounds like the stupidest thing to do and the most boring thing you could do.
Wow.
But obviously that was done for a reason. And the real reason why that's useful to do is you can't do that from Earth. Well, you can do it from Earth, but by far not to the precision levels that Gaia could do it.
Sure.
And also not for the same number of objects. And the real reason why ESA launched this spacecraft was to really make a 3D map, and I'll come to it in a second, I think, but a 3-dimensional map of our Milky Way galaxy. So of the closest or the brightest 2 billion stars, so 2,000 million stars in the Milky Way galaxy.
That sounds a lot, but of course, compared to the 200 billion that we believe there are, or thereabouts, because nobody really knows the exact number, of course, but around, you get estimates between 100 billion and 400 billion. It's somewhere in there.
Yeah.
So there's obviously a lot more mapping to be done.
Yeah, true. It's only 1% of the population of the galaxy.
Yeah.
The good thing, it's not a random. Well, it is a random population, so it's a representative sample that Gaia has been observing. So although you can't observe every star, you can still make very, very valid statistical inferences based on the small data set. So it's like if you have elections, you go to a station, a voting station, and you make an exit poll. You don't have to know what everyone in the country voted to make very reliable predictions. And that's similar to Gaia.
Right, okay.
Yeah. So are there any follow-up plans to replace Gaia with another spacecraft?
Well, there is. So ESA is planning their science missions in programs. So these are kind of the larger views, strategic views where missions live in. And the future program is called Voyage 2050. So that's kind of covering the time interval from roughly now until the late 2040s into the 2050s.
Right.
And there have been a number of, let's say, mission slots identified. And these are identified according to the budget. So you have small slots, medium slots, and large slots. And actually for the second large slot in that program, there has been a study made by community scientists of what would be interesting to be occupying, what mission would be interesting to fly in that slot. And 2 missions have been proposed, or 2 mission concepts. One is a successor to Gaia, and the other one is a mission to do spectroscopy of atmospheres of moderate temperature exoplanets.
Right.
So those two concepts are still kind of on paper in competition, and depending on politics and evolution and technology, in a couple of years, there will be a further narrowing down of those two missions, and ultimately one of those is going to fly.
So obviously you are hoping that they will be a successor to Gaia.
Yeah, of course.
Yeah.
I think it makes sense, and not only for the science, but also because I'm becoming a little bit patriotic now. So Gaia is not the first mission that ESA has done. This mission is called an astrometric mission, so it's about measuring positions and distances of stars. And actually, Gaia was preceded by a previous mission from ESA, Hipparcos.
Yes.
So ESA has now really established themselves as the leading space agency worldwide of being capable and able to do astrometric missions just by themselves. This is purely an ESA mission. There's no partnership with JAXA or NASA or the Russians. It's a purely ESA mission. So I think it's one area where we have really dominated as European Space Agency, as Europe. And I think it would be very sensible to keep that dominance, well, maybe it's not a nice word, but to keep that expertise in-house and to continue on that trend and to make a new mission, of course, not the same, it's not a repeat, but to continue in that footsteps of Gaia.
Yes, and presumably with new technology, there'll be, it'll be even better and more precise and
yeah, exactly.
Would the follow-on mission, do I remember, would it be an infrared Gaia?
Yeah, that's the idea, correct, yeah. So there would be, so Gaia is an optical mission. It measures in optical light, so the light that human eyes can see. And the successor would then ideally fly with a combination of optical light, but also infrared light. Mm. So if you go to infrared light, you are less bothered by dust in the Milky Way. So that's kind of the interstellar matter that is between you as an observer and the stars. And that's particularly harmful in the disk of our Milky Way. So our Milky Way galaxy is a very flat disk of stars. It's a spiral galaxy, and we are basically inside that disk with our sun. And if you look at the night sky on the celestial sphere on a dark evening, you see this bright band of light. That's the hundreds of millions of stars that are all collected there. And actually in that direction where you see the galaxy lined out, there's a lot of gas and dust that is, hindering the Gaia observations. Mm-hmm. And if you would move to infrared wavelengths, that dust and extinction would be a lot less bother. So you could look deeper, and you could also expose, let's say, clusters of stars that are in their formation process and other interesting objects. So it would be building on two aspects. One is to look in a different wavelength regime to open new science cases. And the other element was to combine the new near-infrared data for stars in the visible with the Gaia data that was taken 20 years ago. And then you have an enormous extension of your time baseline. And thereby you make your proper motions. I haven't really discussed those, but it's how stars move on the sky, what is measurable as well. You make those measurements very much more accurate.
Yeah. Can I ask you about the Hipparcos mission as well, the predecessor? How does it compare observation-wise with the accuracy of observations? Obviously, Hipparcos was in Earth orbit, and Gaia has been at L2. Is that a big difference in measurement accuracy?
Yeah, correct. So I would say it's like a demonstrator and the real thing. That's the comparison between Hipparcos and Gaia.
Yeah.
And if you purely look at the number of objects, we went from 100,000 in Hipparcos to 2 billion for Gaia, so 2,000 million. So that's a huge orders of magnitude more. And the real reason why that was possible is because we went from a detector, let's say the sensitive element in your telescope, which could only track one object at a time for Hipparcos. It was an image dissector tube, very classical technology. And for Gaia, we're using a mosaic of modern CCD detectors. And then we can multiplex. We have thousands of stars at the same time in the focal plane. And the onboard electronics is following all of them at the same time very accurately.
Okay.
And then obviously, if you are at L2, you have much less issues with eclipses, because in an Earth orbit, you are always eclipsed every so many hours, and you have a much more stable measuring system. So the precision of the data is also a few orders of magnitude better for Gaia compared to Hipparcos. So it's really orders of magnitude better in many, many elements.
Yeah. Okay, so let's talk a little bit about some of Gaia's achievements. I mean, what would you say have been the biggest discoveries to come out of Gaia? I mean, I know there've been many, but what are the biggest ones?
Yeah, so maybe before I answer that question, let me explain in a minute what we have been doing. So what we need to do with Gaia data is we can't just, when it comes down from the spacecraft, we can't put it out immediately. It's not publishing ready. So what we need to do is we need to collect the data for a couple of years, aggregate it, then process it in a combined fashion in a big or a number of big computer systems to accurately measure what we call parallax and proper motion of stars. So it's basically the perspective effect of the Earth going around the sun. That's the parallax effect, and the smaller the parallax, the further away the star. And the proper motion is just the linear motion or the great circle motion on the sky, which is due to the relative motion of the star with respect to the sun.
How far out can Gaia detect parallax and proper motion?
It can go several kiloparsecs, but if you go to, so that's thousands of light years, but if you go to fainter objects, then the measurement uncertainties also become larger. So it depends a little bit about what parallax accuracy or precision you're happy with. And also, of course, it matters whether you can average over a number of stars. So if you look at a group of stars and you know that they are at the same distance and you can measure parallaxes for 10 of them, for 10 stars individually, then you can make a mean distance to that conglomerate, which is much more accurate than any of the individual distances to the stars. But definitely kiloparsecs away.
Yeah.
So to get back to the question, what we have been doing so far is when data came from the spacecraft to the ground, which was every night, we have been collecting them, processing them, and we have given them out in batches in what we call data releases. And we have done that on 3 occasions. We have made a data release 1, a data release 2, and a data release 3. So the newest data out there is data release 3. That was done in 2022. And that covers the first 30 months of the mission. So a little bit less than 3 years. So all the scientific results that have appeared in the literature so far are only based on the first, let's say, 3 years of data that have been published. And the remaining 7 years are still in the pipeline. So then coming to your question, what is the most exciting that has come out? I mean, there have been more than 13,000 peer-reviewed papers have appeared so far based on Gaia data.
Wow,
so
13,000.
13,000, yeah.
Wow.
So it's more than 2,000 per year. So it's a couple per day. And obviously, I can't go into 13. I don't know even all 13,000. But what really has struck me personally is one kind of hobby field of me when I was a PhD student. I worked on this topic was open clusters.
Right.
So these are groups of stars that are born together from the same gas clouds, and some are a bit younger.
For example,
Pleiades, Hyades, there's a lot of examples, and also visible with the naked eye. Correct.
Yeah.
And these clusters some are young. They are like a few million years. Some are 100 million years. And what Gaia has basically shown is that for a number of clusters, it has accurately measured their content. So it has identified which stars in that area on the sky are proper members of that cluster. So which stars are at the right distance, are moving in the right direction with the right speeds, let's say, together with all the other members, and which ones are just accidental foreground or background stars. But actually, apart from even that common motion that has been measured, Gaia has measured deviations in the outer regions of these clusters. And actually, it has discovered that outside, let's say, this spherical volume of the core of the cluster, these clusters extend along long, what we call tidal tails. So there are kind of tails that really showcase the past evolution of these clusters. So it basically means that the galactic tidal field, all the stars in the galaxy, they have basically been pulling trying to disrupt this galactic cluster, which is internally bound by gravity. Mm-hmm. And it has been slowly pulling away stars, the lightest stars that were least bound, gravitationally bound, from the outer regions It has pulling these stars away, and those have ended up in these tidal tails. And these tidal tails have now been identified by Gaia, and that's a direct proof also that these clusters have finite lifetimes and that they are basically feeding the population of the galactic disk. And I find that was really amazing to really have the measurements, because this was of course simulated before Gaia was flown, but now we have real data where you can see what's actually happening for many, many clusters.
So does this sort of stripping of the material into these tidal tails, does that start immediately the cluster forms?
It's typically takes a while, and it also depends on the orbit of the open cluster. So these open clusters are not sitting still; they are moving. Let's say like the sun is moving our galaxy around the galactic center, and with some particular random component. Also, these star clusters are moving, and some are moving out of the disk and back into the disk, below the disk. So sometimes they are oscillating like the sun is. And it all depends on these parameters and also on how tight they are, let's say, born. So what kind of tidal radius they have when they are born. And some are a bit more dispersed when they are born. Some are tidier. Some have more, let's say, clumps inside them. So they have substructure where it's more difficult to evaporate stars from. So it's also, this is something we have learned with Gaia. Seemingly simple concepts that we thought were true, let's say 50 years ago. If you have better glasses and you look in more detail, things are not as simple as they really look. So with, let's say, opening new levels of measurement precision, you're also going to discover that there's more, issues at stake, and not everything is as smooth or as uniform as you thought it was.
No, absolutely. I'm just trying to imagine what the Pleiades would look like with the tidal tail. Amazing.
Can I ask you about the data releases? Are they accessible by anybody, or are they a closed system?
No, so we have a fully open data access. So while the data is being processed by the what we call DPAC, it's the Data Processing and Analysis Consortium. That's a group of about 400 European scientists in various countries in Europe who actually sacrifice part of their careers to do this nitty-gritty processing. But once that's done, their only mandate is to process the data, to calibrate and to validate. They are not doing science. No. And once we are happy with the quality of the data release, we put it out, and that's the moment when everyone can access those data. And that data basically lives in a database in our ESA data center in Madrid, in Spain. And actually, there's a website, you can go there and you can query that database. So you can, if you have a favorite star, you can find it. If you want to get all of the data, which is a lot, even with this data release free, you can also find it and download it. So it's all there for taking.
Might take some time.
Well, DR3 is still relatively small. It's only 10 terabytes. So I think if you have if you have a hard disk that is a fair size, you can hold it. But for the next data release, we're going to a half a petabyte, so 500 terabytes. And that's not so easy anymore.
No.
True.
Listen, I tried to upload a terabyte of data across the internet a little while ago and failed. It just gave up. So am I right in thinking you have one more data release coming with new data, and then I think in 2030 you're releasing the whole data set? Am I correct in that?
Yeah, that's correct. So there is data release 4 it's advanced in the pipeline. So basically we have subsets of the data already delivered, and we're going to start processing the first bits of the final data in the summer. We are preparing that for publication. And then the hope is that towards the end of next year, we can release that. So that will be data release 4. And that's covering the nominal mission lifetime. So the first 5 years of the mission, plus half a year of the extended life cycle. So 5.5 years of data. And then we have the final data release, number 5, in 2030. That's the baseline, which is going to cover all the data that was collected until 2 weeks ago.
Right. Okay. Yeah.
So let me ask you a question. After Gaia, I mean, how different does the Milky Way look to us now?
I think what we really have learned is that the Milky Way is a living organism. So it may, of course, when you look as an observer and you watch it from the outside, you see the planets move and the stars, well, the Earth rotate, but it looks very calm, right? Nothing is really moving. With Gaia data, we have really seen that there's a lot of activity. So Milky or galaxies, and our Milky Way included, they are, of course, they didn't always exist. They were formed. And this formation is quite chaotic. So over the billions of years since the universe formed, since the Big Bang, structure has formed under the influence of gravity. So there was dark energy, dark matter, and luminous matter. Structure has formed under the influence of gravity, and then the smallest galaxies started to form, and these merged under the influence of gravity. And there has been this hierarchical, let's say, merging up of structure in the universe, where smaller structures became larger, they merged to become larger, etc. And our own Milky Way has gone through a similar process. It has basically been eating continuously smaller satellite galaxies that were passing by. And by cannibalism, galactic cannibalism, it has grown to the size that we know it is today.
Yeah.
And with the Gaia data, we can basically wind back that movie, because for every star, we know their position, but we also know their motion.
Yes.
So we have measured their motion.
Yeah.
So basically, we don't just make a map of the Milky Way. With the motions, you can put them in your PC, and you can put gravity on, time forwards, and then you can move into the future or move into the past. So you can make predictions of how the Milky Way came about and what it's going to be like in the future.
Right.
And looking into the past, we see clear evidence of a lot of these accretion events in the Milky Way, where the Milky Way was grown and collected smaller satellite galaxies. And we still see, let's say, features in motions of stars that are kind of, we see things settling down after collisions have happened of other galaxies with our Milky Way. So I think the one thing that we have learned is that the Milky Way is not a static, boring structure. It's really a living organism or a living structure, which is still ringing and buzzing and trying to get back into equilibrium after being disturbed time after time again by infalling material.
Yes, I mean, one of the things that's come out of the Gaia data is the kink, if you like, in the galactic plane, which is well, if what I read is correct, it's thought that is due to a past collision with a smaller galaxy.
Right.
Yes, correct. Yes.
Yeah.
You refer to the warp, I guess.
Yes.
The tilt.
Yeah. Well,
What about observations from ground-based telescopes? I'm thinking about the Vera Rubin telescope that's coming in online in the next few years. Will that be complementary? Will that be completely different in that case?
Yeah, it has. So actually, it's a very nice complementary project. So it's basically a telescope in Chile, and it's gonna do mapping of the sky. It's basically seeing the sky twice a week in 10 different passbands, and it's collecting all of the data for 10 years in a row. So that's similar to what Gaia does. The only problem for Vera Rubin, or the LSST as it was formerly called, is that this is relative astrometry. So they can measure, let's say, how things move on the sky, and in particular they can look at variable stars and solar system objects. But all of that data processing will have to rely on the reference frame that Gaia has set. So Gaia is kind of the fundamental that defines where the stars are and how everything is tied together.
Oh,
so okay. And Vera Rubin will do the relative astrometry of all those objects in their field of view compared to Gaia sources.
Oh, okay.
But in terms of brightness, it's a very nice extension towards even fainter objects than Gaia can see, because Gaia is limited to, well, it's 2 billion stars. It goes down to 20th magnitude or even close to 21.
Wow.
But it's still fairly bright in terms of what Vera Rubin can see.
Okay.
Yeah, absolutely. Yeah. And I don't know about next couple of years, Michael. I think Vera Rubin's meant to be seeing first light towards the end of this year.
Oh, okay. Right.
Yeah.
I'm obviously a bit behind.
No, they're moving very fast ahead.
Yeah.
They are. I mean, I've been following it since it was the LSST.
Yeah, that's right.
Years now. And
Yeah.
it's exciting to see this amazing project finally come to fruition. But
it's good that the space observatories are sort of linked in a way to ground-based projects as well. Future observations. Yeah.
Yeah,
Absolutely.
I think we have entered an era where doing space missions and also ground projects it's so expensive that you really want to think about complementary benefits. You don't want to just go in isolation and do something which is only of benefit to a small group of astronomers. I think things have become so, because if you want to keep on pushing technology and you want to find new domains, you have to spend a lot of money.
Yeah.
And it's only fair that we do very careful assessments and only fly the best and build the best equipment on ground and in space as well, of course.
Yeah. And of course, NASA are launching Sphere X, the new infrared mapper, later this month. Haven't seen a launch date for that yet, but it's meant to be later this month. And that again will be complementary because that will be an all-sky infrared survey over 102 infrared bands, and that's going to be absolutely stunning. Whereas James Webb is good at zooming in on a particular object, the Sphere X is going to provide an all-sky infrared map such as we've never had before.
Yeah,
that will be very, very interesting as well. Matching all that up with Gaia and Vera Rubin, that will be amazing.
I can't wait until we let loose AI on all these data sets and do some real archive research. I mean, that could be amazing.
Yeah, I might write an article about it, Lou, sometime.
Great.
If you can get me your friend to talk to.
Oh, that.
Yeah.
Yes. Okay. All right.
So I promised Sky Magazine I'd write them an article about AI and astronomy ages ago. And Lou knows somebody who's an authority on AI and astronomy. And
Jos, do you know Kirk Bourne?
No, sorry.
He's an astronomer, worked at Space Telescope and Goddard, and looked at superluminous galaxies, colliding galaxies, and then found his way into data analytics and AI and that kind of thing. And, so, well, we'll keep trying.
Thank you. Your efforts are much appreciated. But it is, I mean, the era of AI, I don't think we fully appreciate how it's going to transform any type of data collection and calibration. It's going to be truly amazing because it will spot things that humans miss, of course. So we hope. So there we are. All right then. Well, Jos, thank you so much for being with us. You are welcome to stay for the rest of the show, but if you have to be elsewhere, then obviously you can go off and be elsewhere. But you're more than welcome to join us for the rest of the show. We'd like to thank you very much for joining us. It's been lovely to meet you. And what about yourself now that you're going to be preoccupied with the Gaia data for a while yet?
Yeah, correct. I still have 5 years of data processing. Well, of course, it's not me. I'm part of a huge team that is doing all that together. Sure. And I'm actually slowly moving into another mission of ESA, which is Euclid, which is a survey mission looking at galaxies.
Fantastic.
Oh, Euclid, yeah.
That's
another amazing mission.
Yeah. Amazing mission. Yeah. Well, good luck with
Ciao,
that.
gentlemen.
Okay. Yeah, we're all very jealous, Jos.
Yeah.
Perhaps we could get somebody to talk about Euclid sometime.
Yeah, absolutely. Yeah, Lou's had to leave us to teach. But Jos, listen, you've got the link for us. You are welcome to come and join us any Tuesday evening if you've got absolutely nothing better to do. You are more than welcome to drop in. Anything you want to share with us, or you just want to drop in for chat, you're more than welcome anytime.
Thank you. Well, it was great being with you guys.
Oh, it's great being with you. Lovely to meet you. Take care.
Okay.
Bye-bye.
Bye. Okay, that was Jos de Bruijne from the European Space Agency. Oh my God, I've got the window seat.
Yeah.
So let's just put things back to normal. Okay, well, let me just have a look. What are we meant to be doing now? Yes. So Michael, tell us about this eclipse that's coming up.
Oh yes, that's right. Okay, I'm going to share my screen in a minute.
I'm just going to make you a bit wider.
Oh.
Ooh.
Oh, no, that's not the one.
Not me.
No, that's not the one either.
Oh, hang on. I've got to do this.
Getting giddy.
Yeah, sorry about that. Can I just say a big thank you to Gerard for your contribution this evening? Very
Oh,
kind of you,
Yep.
sir, as always.
thank you, Gerard.
So yes, just give me 1 second. Yes, the battery's died on my mouse, believe it or not. What I was talking about
Oh
earlier.
dear.
Oh dear.
Give me a
not
second to
great.
check my mouse battery.
Okay.
Right.
Can you see my screen?
Yeah, we can.
Yes.
Right. I want
Let
to
us know
tell
this
you. I want to give you a few weeks' warning of a partial eclipse of the sun that's going to take place on the 28th of March, which is a Saturday, 29th of March. This is how the eclipse will pan out between 10:30 GMT and 11 o'clock GMT, 11:30 GMT rather, and from as viewed from the north of England, to give you an idea how much of the sun is eclipsed by the moon. If you're wondering if it is GMT, it is correct. The BST actually starts on the 30th of March on the Sunday, so it's still GMT on the Saturday. So what's going to happen is, what I wanted to tell you about is, if you want to do any outreach, if any societies want to do any outreach with the community, there's Go Stargazing are providing glasses, eclipse glasses, for people to order in time for the eclipse, to hand them out to their audience for the eclipse. And the web page to go for the glasses is on the screen now, which is the first one. Oops, here. And they are available to order at a very low cost of 50 eclipse glasses for just £10.
Wow, that's
I
cheap.
think is amazing. So if you've got a society that wants to do the eclipse, you can virtually get all these glasses out to all your members and visitors too. So it's a great social thing to do this time, because it's basically the middle of the day. So it's really good timing in that respect for anyone to get involved. So, but if you go to gostargazing.co.uk and search for solar glasses, there is an order form at the bottom of the page of that that eclipse. And just as as an example, these are these type of solar glasses that they will be offering. These were made for the 2017 eclipse a few years ago, so they'll be very similar to this, but obviously for 2025. And that's the Neil, the promoter of this particular glasses, to for anyone to order. So I think that's a brilliant way of doing outreach with a partial eclipse of the sun. Get lots of solar glasses, and anyone can see the actual eclipse take place.
Yes, absolutely. Thank you very much for that, Michael. I know you probably don't need this warning, viewers, but we should point out, never ever look at the sun with the naked eye, even when eclipsed. It's very dangerous. So make sure you've got this type of solar glasses. And we should look forward to a great eclipse in March. And if we can cover it live, we will.
Yeah, we're looking into that, folks. So watch out for that.
What date was it in March again?
29th of March, which is a Saturday, which is great for most people.
Yes.
So yeah.
I'm not sure if it's visible from here. I'll have to have a look.
Yeah.
Anyway, viewers, one thing I just did want to show you very quickly. I talked earlier about the Meet the Astronauts event that we did with the children this afternoon. And one of the schools, I think it's Orkley School, have produced already a lovely poster that I'm presumably going to put on a wall somewhere about Meet the Astronauts. I think this is absolutely fabulous. I think it's great. In case you can't read it, they basically, the speech bubbles contain things that they learned. So we've got I learned that food lasts longer in space from George. I discovered that as soon as you return from space, anything you pick up is really heavy from Ruby. I found that from space, the stars look like they do from the Earth, Rory. I learned that in space, all of the food is mushed up, but it still tastes like food should, from Liliana. And I found out that sometimes space is scary and silent, but it's also amazing. So, and they've got a list of questions there that they ask the astronauts. What has been your scariest moment in space? What's it like to walk or carry things after you've landed back on Earth? What would happen if the spacecraft stopped working in the middle of space? That's a lovely question. Do you have any tips for future space travel? What activities do you like to do in space? And what do the stars look like from space? So that's a lovely thing the school have already produced. So we're very happy that they've had this enthusiasm to do things like that. Okay, well, can I just have a quick look at the chat because I haven't had a chance yet. See who's in. Let's have a look. Alan's there, Ian's there, Keith's there, Derek's there, Stuart's there. Is Sandra in tonight? Didn't see Sandra there. Can't see Sandra there. Well, perhaps Sandra couldn't join us tonight. And Mike Beer's there. And Mike Beer says, Michael, can you put those websites in the chat, please?
Yeah, we'll do.
We'll do that with pleasure for you.
Yeah.
So there we are. Yeah, and as I said earlier, thank you to Gerard for his generosity. Gerard's such a nice guy because he regularly donates to the show. If you want to be like Gerard, we've got absolutely no objection. So let's just have a quick look at how you can do that. And just let me get rid of this comment here, and I'll tell you how you can be a donator to Space Oddities and get your name carved on a wall somewhere. Well, not really, but in my mind, because you deserve it. So first of all, if you would like to support us, you can go and buy us a coffee at the Buy Me a Coffee website. Here's the QR code for it. And this is not the QR code for it. This is the QR code for the merchandise. Let's try again. Okay, so you can buy us a coffee because, as it says, astronomers' lives matter. So buy us a coffee, and you can scan the code there. A link should have just appeared in the chat. And let me just check that has. We can't see it from here, I don't think. Oh yes,
there's something there.
Yes, they fixed that as well. That's good.
Yeah.
Streaming provider. So you can click the link or scan the QR code, go buy us a coffee. Any donation of caffeine, gratefully appreciated. Every bit of money we receive goes into keeping this place running, because we've got cleaners to pay, and we want to get the place decorated, and all that sort of thing. And a new sofa as well we need for our guests. Think of the guests. Do it for them. So go buy us a coffee.
And the presenters.
Very, very grateful. So, Alan says, by the way, Michael, there's an eclipse public meet on top of Barbican near Walsall. Lots of telescopes, but obviously only if clear. That's the big.
I'm hoping to be there, Alan.
Oh, you're planning to be there, are you?
Yeah.
Right. Well, you can be our roving reporter then. Have you got the app on your phone to connect to the studio?
No, I haven't. I'll have to have a look at that.
Download it, and then you can. We can perhaps run an eclipse show. Depending on the weather, obviously. But you can stream from your phone into the studio. So there we are. Okay. Space Oddities shop. I know it's not the time of year for T-shirts, but you might be going abroad somewhere warm to escape the winter. Who knows? But if you would like to buy not just T-shirts, but hoodies to keep you warm in winter, here's the place to go. And let's just put that code up again. So the Space Oddities merchandise shop is here. And again, a link has just appeared in the chat. And we've got T-shirts and hoodies, all very reasonably priced. And we hope you take advantage of those. We've got two designs there. The new design that Michael is sitting in front of that you've probably seen, that's our logo. And we had a previous design as well. So you've got a choice of designs. You can also have the T-shirts fitted with long sleeves if you would rather, for an extra £3 per order. The T-shirts start at £25. but that does include UK postage and packing, which, as we know, is getting more and more expensive in the UK. So that's a jolly good deal. And also the hoodies are £40, including UK postage and packing. If you're outside the UK and you wish to order, please add £10 to the total value of your order. And just to give you an idea of what they look like, so here's the Space Oddities t-shirt. And it says on the front, if it's happening in space, it's happening on Space Oddities, with the address of the YouTube channel. And we've got the hoodies. The hoodies come in two types, over the head or zip up. The zip up ones had the design on the back rather than on the front. So there we are. So thank you very much for that, guys. And that's it. Next week on Space Oddities, I have no idea what's happening, but of course we'll put a show to you together for you before then. What we're going to do now, I think, is we'll go over to Roger's regular weekly spot, and Roger's going to talk us through what's going on in the night sky and also this week's viewers gallery. So take it away, Roger. Let me just do that.
Okie dokie. Right. Excuse me.
There you go.
Okay. Thank you very much. And so we are working our way through the first full week of February of 2025, and we're currently experiencing this evening a first quarter moon heading off towards a full moon. And before I came over into the show this evening, I was outside photographing the moon, and there are a few opportunities this week for some clear skies, so that's a novelty. But there we go. So, okay, so onwards and upwards with what's in the night sky this week. We've still got our favourite constellation of Orion dominating the southern horizons with the moon up, and we've also got Jupiter, Venus, and Mars quite well placed after sunset to look at, and we'll be getting a close visit of the moon and Jupiter on the 7th, which is on Thursday. And also on Thursday, Venus will be at its highest altitude after sunset, and it will be 35 degrees above the horizon. So a good opportunity there. And then a few days later, the moon will have moved over towards Mars for another little photo opportunity, as we can see there. Okay. And before sunset, we do have a very close proximity of Mercury, which will be passing through the other side. So it will then obviously become a morning object. But Venus and Saturn are still reasonably close together, and obviously Saturn now getting rather lower in the night, in the evening sky. So opportunities are now rapidly diminishing, unfortunately, but there we go. But obviously during next month we'll have the edge-on effect of the Saturn's ring, so another opportunity to see something different that some of us have probably not seen before. Okay, so we're going on to a gallery of quite a good number of entries that we did get. And just to be aware, all these pictures that I will be presenting are already on the website. So if you wish to see all the latest images and anybody else's images that has been submitted, then they're all in their own individual folders. So worth going to have a look. Okay, so we've got an image from David Garside of the Witch's Broom in Cygnus. And this is with 3 hours of integration. And this is what he has produced.
Oh, wow.
That's some nice structure there.
Yeah, definitely. Wow.
Very good.
Oh, yes.
Yes. This is one that David had accidentally sent to the old Space Oddities website, but we have got it now, and everyone can admire it.
Thank you, David. That's a lovely image.
Very well done. Okay, so we're going on to Alan, and he's got one that he took a little while ago, and then he's got one. And he says there he's got all 5 of the planets here, which was taken 22 years ago. So we've got Mercury, Venus, Mars, Saturn, and Jupiter all in one image.
Wow. Isn't
Wow.
that amazing? Gosh.
Yeah, quite an awesome sight there.
And I was just wondering if any viewers actually went out and saw the planetary conjunctions last week. Well, of course, they're still roughly in a line. But of course, there was a lot of hype in the media because you can't obviously see Uranus and Neptune with the naked eye. But you could see the other 3.
Yeah. Of course, Mercury is a bit difficult because it's so close to the sun. So that was no way of showing that. But there we go.
No.
But this was the evening. The cloud was solid with a narrow gap above the horizon, and Jupiter was lost in the cloud. So this was a brief encounter before they were all become visible again. So there we go.
Beautiful, absolutely beautiful.
Yeah, seeing Mercury is a bit of a unique experience. You have to be very fortunate to be able to get it with a good, clear, low horizon. So,
I think I've only seen it once personally.
I've never seen it. I've never managed to see it.
Right.
Yeah. The only definite way of seeing it is with a transit, and that doesn't happen very often.
Right.
No.
Oh yeah, true.
Yeah. So we're off to see the sun with Graham Turvey, and this was with the Sea Star, which he managed to get out when there was an actual bit of clear sky to see, and this was at the end of January. And there are some sunspots appearing coming round there, which is a nice thing to see.
Absolutely.
I've not managed to do much this year at all with the solar imaging due to the awful rubbish weather, but there we go.
It'll get better, Roger.
It can only get better.
Yes.
So Jerry DeLay has submitted his Christmas Tree Nebula, Cone Nebula, and the Fox Fir Nebula, and we all like to see that. And this is what he's managed to produce.
Wow. That's
that's lovely.
That's amazing. That's
lots of gas there, details, amazing. Well done.
Is that also known? Is that Christmas tree? Is that also known as the Cone Nebula?
Yes, that's correct.
Okay.
Yes.
Amazing.
Well done. Sometimes you usually see it with the Cone Nebula at the bottom,
right?
Pointing up.
Yeah.
Or from the top down, just depends on which way you do it, really.
Yeah.
So Michael's managed to get 2 Messier objects in this one image with his ASCAR and camera setup, and there's the owl right in the middle.
Yeah.
Oh yeah.
And if you look closely enough, you can see the little eyes that help to define its description. Which is quite fun, and very good.
Very nice. Well done.
Well done. Yes, 2 with 1 image. How good is that?
Yeah.
And here's an interesting creative picture from Lee, who has called this Orion Call the Doctor. So he's got a little head torch, and he's got a little mini police box as a foreground object, with Orion in the background.
Oh, nice!
That's lovely. That's very
even though it's way out of focus, it does show the colours of the stars in Orion very, very well.
That is one effect that you can do with photography. Is if you take the stars out of focus,
you can see the colours better.
Bring up the accurate colours of the stars.
It's really red, isn't it?
At least the TARDIS is in focus.
Yeah. Yeah, we like that.
We like that, yeah.
Doctor Who and the Shoulders of Orion.
Ooh.
Oh, well done, Lee. That's really good.
Yeah. So Graham's taken a Sea Star picture of the moon on the 2nd of February. and just quickly tweaked it. A one-off pick, and
Oh, very nice.
got a very nice crescent there.
Yeah.
That's beautiful.
Very good. Very well done.
Yeah, the sea stars are amazing.
They are very good.
Yeah.
And he's also did one of the Horsehead Nebula, which was taken on the 2nd of February. And it's 100 minutes of 10-second exposure. So quite a good amount of lights coming in through there. And yeah.
Wow, that's amazing.
Yeah, that's not come out too bad, because you've got Alnitak there glaring away on the left.
That's
and
not
it's managed
is it? It's just
that's come out very well.
Amazing.
Well
done.
Okay, well done. And one from me, I'm afraid. And this was last night's moon, which was at 32%.
Oh, that's nice.
Oh.
Yeah, I like that.
Yeah, I like the way we've got Aristillus and Theophilus and Priscillus there down on near the Terminator there to get all the details of the rims and the center peaks of the craters there. Went quite well. And that concludes this week's news and gallery of what's in the night sky.
Thank you very much, Roger. And you know, as I always say, oh, my camera's off. Just one second. As I always say, keep those images coming in. We love looking at your images. We love showing them to our audience. And if you would like to send your images into the gallery to be displayed like this, then just attach them to an email, and one image per email, please, and mail them to gallery@spaceoddities.space. That's gallery@spaceoddities.space. They will be featured here and also on the website, where you, if you submit images, you have your own little gallery on the website. And
yeah, they're all there.
All there, to be more exact, here. And and as you can see, everybody who contributes an image gets their image shown in your own little gallery. So, for example, if we take Lee's, we can go and look at all Lee's photos, and if we take that one that we saw earlier, call the doctor.
Yeah.
Then you can see it, and then there's an icon here. There are all the details on the right, and then you can click this icon to see it full screen.
Yeah.
So you know, if you want your own gallery to show to people, say, look what I've done, then that's how to do it. So,
like what I do.
Look what I've done, and you all done very well.
Yes.
Sound like old Mr. Grace, don't I?
Exactly.
You've all done very well.
Very well.
And I was going to say about the police box, actually, some of us are old enough to remember when there were police boxes everywhere.
Not quite.
All right.
You don't remember police boxes, Michael?
No.
Do you still see them occasionally?
Yeah, you do. I have seen them, but not like you say.
Yeah.
Obviously, only phone boxes, the old red phone boxes, yeah. But,
but the police ones, there are a few still. I've seen a few in London. There's one up near Watford somewhere I saw a few years ago. It seems incredible now that for a policeman to communicate with the police station, they had to go and find a police phone box. And they had to say to the person they'd apprehended, can you just wait here while I just have to go and make a phone call. Just don't go anywhere. Just stay exactly where you are, if you don't mind. If you would be so good, that would be awfully good. You can sound like Sergeant Wilson now as well. Would you mind awfully just staying there?
Yeah.
So there we are. Okay, right. Let's rock and roll. Let's move on. So tonight, next tonight, we're going to go over to the news for this week. There's been quite a bit of news tonight, so let me just sort myself out here, and I will bring you the news. Some really interesting things in the well, every week there are really interesting things in the news. So let's have a look and see what we've got coming up with the news. And hang on, just 1 second. Give me a second. Right. Okay, so This week in the UK is National Astronomy Week, and events going on all over the UK this week. If you didn't know, it's National Astronomy Week. The website you need to go to is astronomyweek.org.uk. And if you go there, you can find out the details of events happening near you. And there's an interactive map there on the website where you can click each flag and it'll tell you what the event is. As you can see, there are hundreds of events going on all over the UK and in Northern Ireland to celebrate astronomy. But it's also European Week of Astronomy. So this is happening all over Europe. It's a week of Europe and the UK, or the European community and the UK, because of course we are in Europe. But let's just say Europe celebrating astronomy, and events going on everywhere. And, you know, it's especially great if you can get kids involved, because it's really, you know, should be all about the kids, enthusing kids to get interested in the universe above our heads. So it's Astronomy Week National Astronomy Week in the UK. Do go and have a look at astronomyweek.org.uk and find out what's going on near you, and try to get to you know, a few of the events if you can. So there we are. Got some little bit of possibly bad news. Earth is under threat from an asteroid, as you may have seen in the news. Now, I know if you read popular media, you see asteroid threats coming up all the time. In fact, I think it was the Daily Express that holds the record that in 3 months they published nearly 80 asteroid threat scare stories. When it's a slow news day at the Daily Express, what are we going to publish? Oh, let's make up some scare story about asteroids. Well, this one is for real, unfortunately. Otherwise, we wouldn't be bringing it to you. And let me just tell you what this is all about. It's an asteroid called 2024 YR4. It could strike the Earth on the 22nd of December 2032, so not many years away. It has a 1 in 77 chance of an impact with the Earth. Now, that actually is not high odds when you think about it. There's a bit of uncertainty about where exactly the asteroid will be on the 22nd of December 2032. And in fact, there's an uncertainty of about 10,000 kilometers. But as our planet is 12,000 kilometers in diameter, it puts us very much in the target zone for that. And it's 60 to 70 meters in diameter. Its composition is unknown, but in 2028, it's going to approach the Earth a lot further away. And obviously, astronomers will be studying it really closely in 2028 to try and find out a lot more about it. It's probably a rocky asteroid, but there's a possibility it might be metallic. Now, if it's a metallic asteroid, that's particularly bad news. Why? Well, because it would have a much higher density than a rocky asteroid. Also, it's less likely to break up in the atmosphere. So it has a much higher chance of hitting the ground intact. And scientists are studying how to counter this threat. But obviously, until they know the composition of it, we won't be able to put forward any plans for doing something about this. And there's no planetary defense system in place yet, but there is talk already of launching spacecraft with, believe it or not, nuclear bombs to try and destroy it. We already know from the Dimorphos collision that NASA did, where they actually managed to divert the path of an asteroid, that it can be done. But there are so many variables in this that until we know more about this asteroid, you know, we can't really make any plans. And this is the beast in question. It's that dot right in the middle that's not moving relative to the stars. And this is the actual asteroid that could impact the Earth on December the 22nd, 2032. Now, if you're wondering where it might hit on the Earth, well, they projected where it might hit. And it's here. It's this red line, sort of from the north of South America across Africa and into Asia. This is projected to be the impact zone on that day, but obviously it could change. So, you know, this having an asteroid that's got a 1 in 77 chance of hitting us, that's not high odds compared to most other threats from asteroids. So we'll just have to hope that nothing untoward happens. We don't want to scare anybody, and we don't want anybody to lose any sleep over it. But these are the facts that we know. Obviously, that the Earth is going to get hit by an asteroid in the future. Could this be the one? And obviously, it would detonate with the force of many atomic bombs, something that size, were it to impact the Earth. But as you can see, it's got a very good chance of going into the sea. But then you've got the risk of tsunamis. So we'll just have to wait and see. But, as I said, we don't want to scare anybody. But these are the facts as we understand them at the moment. The 2028 encounter should give us a lot more data. So there we are. We mentioned this earlier when we were talking to Jos. NASA are launching a new space telescope later this month called Sphere-X. Now, Sphere-X, as I said earlier, is an infrared mapping telescope. And it has the most unlikely acronym. Sphere-X stands for the Spectrophotometer for the History of the Universe, Epoch of Reionization, and ICES Explorer. That has to be the most contrived acronym ever, I think. And there we are, bottom marks for the acronym, guys. It's going to conduct this all-sky infrared survey, mapping the cosmos in a way we haven't been able to do before across our 102 infrared bands. As I said earlier, the JWST is great for zooming in on individual objects, but this is an all-sky survey which will be able to map the entire sky. And it will enable astronomers to identify targets to point the JWST at and other telescopes. So it's a sort of a universal guide to the cosmos. And it's expected to operate for at least 2 years, scanning the sky every 6 months and offering unprecedented insights into the formation of galaxies, cosmological inflation, and the building blocks of life. So if we can bring that launch of the Sphere-X space telescope to you later this month, we fully intend to. We haven't got a launch date for it yet. Michael, have you seen a launch date for it? Michael? Can you hear me?
Sorry, I was on mute.
Right.
I'll have a look and let you know in a few minutes if I'm
could you check out, because last time I looked there wasn't a launch date for it.
Okay.
So there we are. And its objectives are to identify large-scale cosmic structures that could shed light on how the universe expanded after the Big Bang and map out the chemical composition of interstellar space to trace the origins of water and organic molecules. So we've got that to look forward to.
Yes, I have got a launch date.
Oh, great. When?
The 28th of February.
Oh, soon.
0310 GMT.
Oh, right. 0310 GMT.
Middle of the night.
Right, middle of the night.
Guess we won't be covering that one.
No,
then.
I don't think so.
Well,
it's been launched from Vandenberg.
From Vandenberg. Okay, yeah. Thank you. Well, I mean, I'm up for it if you guys aren't. So,
you're on your own then.
I think I'm on my own. All right, viewers, let's rephrase that. Not we will bring you the launch. I will bring you the launch. So that'll be something to look forward to on the last day. Is it the last day? Yes, it's not. Is it?
28th, yes.
28th, last day of February, launch of Sphere-X to carry out this amazing infrared whole sky.
Yeah, it's been launched with a satellite called Punch.
Called what? Sorry.
Punch.
Oh right. Okay.
Oh right. That's the way to do it.
Very good. Very good. Boom boom. Right. Okay. So moving on. China, of course, is very busy in space these days. Their space program moves on in leaps and bounds, having a seemingly unlimited budget. Their latest wizard wheeze is that astronauts on board the Tiangong space station have managed to create rocket fuel in space. This is quite an amazing step forward. So basically what they've done, they've got this new process they call artificial photosynthesis, energy coming from the solar panels on the space station. And as the South China Morning Post reports, they've managed to produce the necessary ingredients of rocket fuel, as well as oxygen, which is obviously also useful in space. And they've done it by using semiconductor catalysts to turn carbon dioxide and water into oxygen and ethylene. It's a hydrocarbon commonly used to produce spacecraft fuel. And as I said, they use the energy from solar power. Now, this is big because if you've now got a process where you can convert carbon dioxide and water into rocket fuel and oxygen, that's going to be really useful for China, especially as they're hoping to establish a base near the moon's south pole by 2035. And they will require a steady and reliable source of breathable oxygen, and of course rocket fuel that they can fuel their rockets going back to the Earth with. So this is going to be great if they can set this process up on the moon and generate the rocket fuel and the oxygen that they need. But you know, this is a big step forward, being able to create rocket fuel and oxygen in space from the same process. So there's no word yet on how much it costs to do that, or how much the output is, how long it takes to get a particular quantity. But it's you know, it's never been done before. So well done, China. This is a bit of a first. We're going to move on now to talk about asteroid Bennu. Now, you may remember the Osiris spacecraft briefly touched down on Bennu to grab some of the surface to bring it back to Earth, where it was delivered on a capsule into the middle of the desert in America. And there you see two technicians holding the return sample in very, very clean conditions, which it has to be. There have been some quite amazing discoveries about the sample from Bennu. Now, what astronomers think is that Bennu was once part of a much larger body that had water on its surface. And we're talking about the early history of the solar system now. So Bennu is a bit that broke off, probably in some sort of impact. And what have they discovered? Well, first of all, the sample contains all 5 of the nucleobases that form DNA and RNA. As you may know, DNA and RNA come in 5 bases, and T, R, C, A, and G, is it, I think? And another one, I can't remember. I should know this stuff. But amazingly, it also contains 14 of the 20 amino acids found in known terrestrial proteins. So the fact that you've got 14 of the 20 amino acids that are found in basically life here on the Earth is absolutely amazing. But it's not as simple as it sounds, because these amino acids on the Earth typically have what's called a left-handed chemical structure, because life is not ambivalent, if you like, for left and right-handed formation. It's normally left-handed. Bennu appears to contain nearly equal amounts of left-handed and their right-handed or mirror image forms. Nobody knows what this means at the moment. So it's like life on Earth, but it's not exactly the same. There's something different about it. Don't forget, this is not life. These are the building blocks of life. There's also evidence for these saltwater brines that existed or said to exist on the parent body of Bennu billions of years ago. And the findings show that conditions would have been ideal for these molecules to interact together in this briny sort of sea or lake or whatever it was. And it does strongly suggest that conditions for life, for the emergence of life on Bennu might have been widespread in the early solar system. So again, it comes back to the old question, is there life elsewhere in the solar system? Because Bennu contains directly the building blocks, the amino acids and the nucleobases for DNA and RNA that we consider that you need for life. So there we are. So that's it for the news. Some amazing finds there. And so what do you think of that, guys? Absolutely amazing, isn't it?
Yes, definitely.
Yeah. And, you know, I mean, I'm still convinced that once we get out into the solar system, either by sending people or sending more robots, I'm convinced we're going to find some form of life in the early solar system. I really am. So there we are. So that's the news for this week. Hope you enjoyed that. Now we're going to move over to Roger again. Roger is going to deliver, fanfare please, our constellation of the week. Now, don't forget, we started this 2 weeks ago, regular feature, constellation of the week. And I'm going to hand you over to Roger now, who's going to tell you exactly what this one is. So there you are, Roger.
Okay, so this week we are going to go to Cassiopeia. I just hope I've spelt it right. Okay, so we have got Cassiopeia for this constellation of the week. As many of you know, it's directly opposite Ursa Major, the other side, and is famously known to be recognized by its W shape. And it's also a circumpolar. So here I've got the constellation Cassiopeia above Polaris at its peak right on the top, and when it's done a 180 degrees, it's still quite visible to be spotted. So that's all well and good. And obviously we've got it through the some of the Milky Way there. So some interesting objects to be seen from our viewpoint. Okay, so this is Cassiopeia, but without any markings. So let me just go through the main stars and also their names. So we start from right to left, and we start off with Beta Cassiopeia as Caf. Then we move down to the brightest one called Shedar. It's spelled either Shedar or Shedar.
That's an
depending on
name. That looks sort of German or Dutch or something.
Well, you usually find that a lot of the star names are either Arabic or Greek.
Yeah.
So that's how it is.
That doesn't look like either, actually, does it?
No. Anyway. So
anyway.
we go to the middle, which is Gamma Cassiopeia, which is Navi. And then we move over to Delta, which is Rushbach.
I like that.
That could be German.
That could be German, yeah.
And then the final one on the end there, Eta Cassiopeia, is Sagan. No relation to Carl Sagan, spelled differently. One vowel.
Well, I like the
and
name.
that gives us the recognizable W shape of Cassiopeia.
I like
but
Ruchbach.
I looked it up. It's from the Ruchbach is from the Arabic word for knee.
Oh,
right.
There you are.
Right.
So it's
because if you rotate the constellation of Cassiopeia around 90 degrees counterclockwise, Cassiopeia, the character from which this was created, that would be roughly where her knee would be.
Of course.
Yes. So there we go. Okay, so we've got a few interesting objects. There's a couple of Messier objects. We've got this one, which is Messier 52, which is in my photograph here as an open cluster.
Okay.
But if you're more interested in what's just down to the southwest of it, we've got the Bubble Nebula, NGC 7653, which is quite an interesting target to photograph. That's a general wide field view of that object. But the image on the left is not mine, it's a Hubble image, but it just gives you an idea of some of these interesting structures that can be found in these gaseous nebulae.
Yeah, lovely.
So that's over towards the northeast part of the constellation of Cassiopeia. And then over towards the middle star of Navi, we've got the Ghost of Cassiopeia. Now, this is a reflection nebula, and that is all being illuminated by the star Navi, which is the central middle star of Cassiopeia. And it's quite an interesting object to collect. This one is my own image, and yeah, quite an interesting target.
Wow,
okay.
That's beautiful.
Yeah, you can just see how much the reflection is from Navi. It's a bit like the witch head being reflected by Rigel in Orion there. Similar sort of process.
Yeah.
But obviously with different gases giving out the different colors here.
Yeah.
Okay, so we've also got another open cluster just over a bit further over to the west, and that's M103. And here's a closer view of it.
Yes.
Nothing really spectacular, but I'm not particularly interested in open clusters because they can be sort of very
Don't tell Jos.
glorious. Yeah, they're. But that's how it goes. So that's the highlights of the constellation of Cassiopeia. So I hope you're a little bit more aware of what the constellation consists of and any interesting objects that you might like to capture with your telescope or sea star.
Absolutely. Absolutely. Now, viewers, if you have a suggestion for a constellation of the week, one you think we should examine, then tell us in the chat, or you can email us at any time, of course, at our usual address, info@spaceoddities.space. That's info@spaceoddities.space. Always love to hear from you. If you want to drop us a line about anything, in fact, then if you want to, send us an email telling us how wonderful we are, we're always up for that. And ransom notes, kidnappings, threats, anything you like, then send it into info@spaceoddities.space, and it'd be lovely to hear from you. All right, well, I think that wraps things up for this evening. We'd like to thank Jos from the European Space Agency for being our guest this evening. Thank you, Jos, and very, very interesting information about his work with the Gaia telescope. And we hope we'll see him back on Space Oddities at some point. We will be back, of course, this time, or 8 o'clock UK next week, where we'll have even more fun and frolics with the cosmos. So we'd like to wish you all a very good week. Take care of each other. Be good. If you can't be good, be average. That's what I always say. And thank you so much for joining us. Don't forget, if you would like to buy us a coffee, I'll just put this up one more time. You can scan the code, or you can click the link in the chat to buy us a coffee. If you would like to make an actual donation, then we'd be very happy with that as well, of course. I'm very grateful. So in the chat window, underneath the chat window, you'll see an icon with a $sign on it. You can click that to make a donation directly to Space Oddities. Every bit of money we receive goes towards keeping Space Oddities running, and we'd like to keep it running for you guys out there. So if you would like to do that, then you're more than welcome. And thank you so much for your generosity. The generosity of our viewers is wonderful, and we do appreciate it. So thank you very much. All right, then. So we'll be back next week. Keep looking up. So from Roger, from Michael, and myself, we'd like to wish you a very good evening, and we'll see you next week. And thank you for being here. Bye-bye.